So we are now speaking about what's new for OCP 2.1. And as Hannah already introduced ourselves, I will start with a short introduction, and then I will hand over to Frank, who will guide you through the majority of the technical parts. If you want to also reach out after the meeting directly to us, you can also contact us via email, of course. And as Hannah already told you, if there are any questions, please put them into the question box, and we will try to answer them then at the end of this presentation. So a short introduction. So where we came from, so to say. So already almost 10 years ago, OCA published OCP 1.6 with these 5 functional blocks at that time. So we have firmware management, reservation, local authorization list, smart charging, and core. And then a few years later, we decided to publish OCP 2.0.1. And by doing so, we made some big changes in the architecture and in the design of OCPP. This means we were able to fix some flaws we have had with OCP 1.6. But the downside of this was that if you wanted to migrate to the new OCP version, you have to undergo some important changes and some huge changes in your software implementation. And this made the migration or the adoption of OCP 2.0.1 not easy, at least. And for the new release, OCP.1, we tried to change this. So therefore, we tried to be as backwards compatible as possible. And by doing so, we wanted to ensure it is a smooth transition from 2.0.1 to 2.1. And this will also mean that, that the effort in migrating from one OCP version, so 2.0.1 to 2.1, will be much less effort than compared to what was the effort for 1.6 to 2.0.1. So maybe Frank, you can go to the next slide. So, and to make this even more easier, we added on each use case, which is new in OCP 2.1, a short text saying that this is new in 2.1. So this means if you want to scroll through the specification, you will see on use cases and also on paragraphs describing certain matter, you will see this here new in OCP 2.1 or updated in 2.1. Which will mend and will jump directly into your eyes that there has something changed there. And this is also valid for requirements. So you see an example here with also the 2.1 mark on it. And this means if you see such a requirement, this was changed. And as I already said that we wanted to make the migration as smooth as possible, the majority of new features are introduced by either new messages or by new optional fields in messages. And to be able to also spot them pretty easily, we added also here the flag. So if you now scroll through all the data types and the messages, and you see here also the 2.1 flag, this means this functional block or this field in this case is new in OCP.1. Okay, that's for the introduction now. Frank will guide you now through all the changes in detail by section. So I will hand over to you, Frank.
Yeah, so hello, good afternoon or good morning, depending on where you are. I will guide you through the changes in 2.1. I will do it in the order of the functional blocks that they are in the specification, and that also means that the highly anticipated change with support for bidirectional charging vehicle to grid is near the end of the presentation, so you will have to hang on a bit. So here you see the first 5 functional blocks from OCPP. And I did with a short summary of the changes. I'll have 2 more slides with a little bit more detail coming up next. But you see we have a minor change in security, where we had to update something about the charging station certificates, specifically for ISO 15118-20. Then in the provisioning block, we have a new reset message that allows you to reset an ongoing transaction and then resume the transaction again afterwards. So that's a minor extension of the reset message. And then in the authorization block, we have quite a few changes because we introduced support for prepaid cards, support for payment terminals. And there was some support for payment terminals already in 201, but it was very limited. Now we actually have a whole list of use cases, like you can see here, with authorization via payment terminal, cancellation prior to transaction or cancellation after transaction, settlement, what happens if settlement rejects or fails, etc., and an ad hoc payment. So I have slightly more details on that on the next slide. And we're also, you see it on the right side, a few deltas on the existing use cases of OCPP 2.1, also mostly dealing with the new 15.11.8-20 support. Then in the transaction mechanism, block E, we have added a transaction mechanism to support limits for fixed cost, energy, or time. So to give you some more details on the authorization enhancements, we now offer support for prepaid charge cards, where, for example, if you start with a prepaid charge card, the CSMS can automatically set a max cost limit on the transaction to make sure that you can never exceed the balance of your card. And in order to properly calculate a maximum cost, you should also implement local cost calculation, because then the charger can itself calculate when the charger has to stop when it reaches the max cost. The local cost calculation is something of the block I, tariff and costs, which will be in one of the next slides. Then we have now much better support for ad hoc payments or direct payments. And for this, we have a specific component, the payment controller, where you can configure all kinds of properties of the payment terminal that you have in the station. And we have a specific token type, the direct payment token type. And then with that token type, we can send all kinds of additional info data about the credit card, for example, the last 4 digits, the expiry date, what it was, an American Express card, or you used Apple Pay, or things like that. It can all be communicated in the authorized request now when you do direct payment. And then, of course, if the payment is being settled in the charging station, you want the charging station to inform the central management system that the payment has been settled or that it succeeded. That's now also in there. And again, here the transaction limit mechanism can be used here to limit your transaction to the amount that was authorized for the credit card. Then for chargers that are not supporting integrated payment terminals, for example, public AC chargers, but that do want or have to, because regulation have to support direct payment, we now support ad hoc payment via a dynamic QR code. So not a fixed QR code with a sticker, but a dynamic QR code on the screen. You can configure the parameters for that in a new web payment controller. And it's it uses a time-based one-time password. And the algorithm for the one-time password is also defined in the OCPP spec to make sure that both the CTMS and the charging station use the same algorithm. And then I already mentioned that a few times, the transaction limits were added to the transaction event. So we have 4 types of limits: cost, time, energy, and state of charge that you can specify. And this limit can be set both by the charging station and probably because, for example, the user inputs that at the station, or it can be set by the CSMS. You can use that for prepaid cost limits, or if there are some limits defined by the network operator, or maybe if the transaction was started by the user via a mobile app and provided some cost limit, for example. So I think it's a flexible mechanism, and it has proved already very useful in the prepaid card and the payment terminal use cases. Then, of course, block F is the remote control, the remote start transaction, basically. And the whole support for fixed cost, energy, and time is also in those use cases, so that will not be a surprise. There'll have been no real changes to availability and reservations, but tariff and cost has undergone a major overhaul. So because now in OCPP 2.1 we support local cost calculation, and we provide you are able to provide a tariff structure that exactly defines how to calculate the cost at the station. And before I dive into a little bit more details on tariff and costs, the block J, the meter values, has been a minor delta on that, mainly because new measurements exist now that we do bidirectional charging as well. So the tariff and cost details. We have two ways to set a tariff. We can set a default tariff, which is used if you do not know who the user is, for ad hoc payment. We use the set default tariff request for that. You set that once on the charger. And we have a driver-specific tariff, which can be returned in the authorized response. So when the driver authorizes, then in the response you can return the driver-specific tariff. Apologies. The tariff structure can be quite complex, but you can also start really simple. You can have a really basic tariff based on kilowatt hours, time values, and fixed fee. But if you want to, you can have conditions on all these values, depending on date, time, day of week, amount of power, amount of energy, whether you're currently charging or whether it's idle time. So you can specify all kinds of conditions there. And the charging station can communicate in the device model whether it supports only the simple tariff or it supports the full structure with conditions. So also really simple low-end charging stations which might only use a simple kilowatt-hour tariff can use this tariff structure. And we have also made sure that the OCPP tariffs can be mapped from tariffs published by OCPI, or those by Hubject, or those by e-clearing. So we check that those tariff structures are mappable onto the OCPP tariff. And then we get into a block with a lot of changes. That is smart charging. And smart charging was changed for, or enhanced for various reasons. First of all, we now support 15.11.8-20. 15.11.8-20 has different charging parameters, for example. It has a dynamic control mode next to a scheduled control mode. And we also had quite a few extensions to smart charging as a result of the introduction of bidirectional charging, which will be in one of the next slides. But bidirectional charging is basically a special form of smart charging. So a lot of the bidirectional enhancements actually affected also the regular smart charging. And it's all enhanced a new feature, so it doesn't exist your existing smart charging process in any way. You just have more possibilities now. Now the next slide on the more details on smart charging. And then what was there more? Certificate management. There was an update again for 15.8-20 certificate installation. And the diagnostics block, we added a new feature called periodic event streams, which I will go into more detail in a minute. So the smart charging the details. As I mentioned, we need to add a whole lot of new charging parameters that you can get from a 15.11a-20 session. And we added support for dynamic control mode. That's also something that -20 supports for vehicles. And as a counterpart of dynamic control mode in 15.11a-20, we now also have dynamic charging profiles in OCPP. And basically, a dynamic charging profile is a profile that you can, in which you can update the limits on the fly without having to submit a new charging profile. This allows you for quicker adjusting of values, something that can be really useful. For example, if you have changes that you cannot anticipate, or if you want, for example, to adjust your charging based on the amount of solar generation, and suddenly a cloud comes in front of the sun and your solar generation drops, you can really quick update your charging profile with the dynamic charging profile. And I'm also almost forgetting the new priority charging. Priority charging is this new specific charging profile purpose that can be used to overrule any smart charging or bidirectional charging profiles that you have active. Of course, assuming that the operator allows it. It's something that you can enable or not. And priority charging, for example, allows you to have a button on your charging station. If the user presses that button, then your smart charging limit is overruled and the user gets the amount of power that is defined in the priority charging profile, which would, for example, be the max profile. And this is also something you can use to overrule discharging if you don't want it. It can be done both on the station or via the central system. Finally, I already mentioned the dynamic charging profiles that can be of use when you're dealing with think of solar energy. For that, we also have now the so-called local generation profile. A local generation profile differs from the regular charging profiles in the sense that it specifies the amount of locally available power. So instead of limiting it, it is actually something that you have extra. So if the CSMS sets you a maximum charging limit of 8 kilowatts, and your site has 3 kilowatts of local generation, then the vehicle would actually be able to charge with 11 kilowatts. And this can be very convenient for these kind of situations. And with that, we also run into the issue of energy management topologies. What I'm showing now is not really new. It was already possible. It was already possible in OCPP 2.1, but we did not have any use cases defined on how to deal properly with energy management systems. So now in OCPP 2.1, we show a number of use cases. For example, here you see an energy management system that's controlling two charging stations, and it describes how you can deal with that. Or another situation where you have an energy management system that speaks with a local controller, and then the local controller takes care of the charging stations. Or we can have an energy management system that acts also as a local controller. So it's like an OCPP capable energy management system. or the so-called hybrid situation, where you have a cloud energy management system that is also controlling the charging stations, but you have a local EMS on site as a backup, and also to guard, for example, against the grid connection, so that you don't blow any fuses. Again, here are some variants as possible. You can also have the local EMS be the master, and it gets its data from a cloud EMS that more or less functions as a scheduler. And then finally, we also have a use case that describes how you can use the local generation profile, for example, to be purely charging on the amount of energy that your solar panels generate. So again, this is not new, but I think it clarifies a lot on how you can deal with external actors or energy management systems in OCPP 2.1. Okay, and then I mentioned that for diagnostics we have a new type of message, the so-called periodic event stream. And this is a mechanism that is optimized for sending high-frequency periodic monitors. Because in 2.1, if you have a high-frequency monitor, for example, that would send you the voltage every second, you would almost overload your communication channels, because the notify event message is quite verbose. And now with this method, if you define a periodic monitor and specify the flag that you would like to use the event stream, then this will open a kind of a stream. I mean, it still uses the same WebSocket, but it will send all the data in batches that you define. For example, send me 10 data, 10 values at a time, or send me the values every 10 seconds, something like that. And it will only send the values with a timestamp and not all the overhead from the notify event message, because that was already provided once. So I think that's a great optimization in your communication overhead. And also, this message does not need to be replied upon. So it's a fire forget, there's no response for it. That also saves a lot of time. And two more minor extensions, that we now have two different kind of monitors, the target delta and the target delta relative. How much do you differ from the target that was specified to you? And a so-called data collector component for local logging of values. If you really want to log high frequency values, for example, if you want to test your frequency response system or something, you can gather this data locally on your station, and then via a new get log request of type data collector, you can then download all these values. Well, and then we get to three entirely new functional blocks, namely Q, the bidirectional power transfer, R, the DER control, and S, the battery swapping. Let's first go to the bidirectional power transfer. So this is the section for all the vehicle-to-grid support. And we support the discharging via SHADEMO and 1511.8-20. You will see in the documentation, SHADEMO is also mentioned in all the sequence diagrams, but most of the added messages for OCPP are related to 1511.8-20, because that protocol provides a lot of extra information that you can use for discharging, whereas SHADEMO is a bit simpler in that respect. We designed all this bidirectional charging as an extension of smart charging. So what we did, we extended the charging profile schedule periods, where you have a limit. We added now also a discharging limit, and we added a set point and a set point for reactive power, for example. And you also can add the limits per phase, because that's something that 1511.8-20 allows you to do. So you can still use the same charging schedule with limit only for the regular smart charging. And if you want to do discharging, you would also specify, for example, the discharging limit in that schedule. And we specified a whole list of 8 or 9 use cases, I think, that describe how you can do bidirectional charging. The most common ones will be the central set point situation, where the CSMS sets the set point for the amount of power that you want the vehicle to charge or discharge. But we also have a use case that describes how, for example, an energy management system can do that, or how a local charging station itself can do it locally. And we have a new field called the operation mode that specifies whether you're now working in central set point control, or you're working with external set point control, or whether you're doing local load balancing, or whether you're not really there to charge the car, but you are there to provide frequency support. That's a whole different use case where you can configure a frequency watt table, and then if the frequency deviates from its nominal value, then you can let the vehicle automatically start charging or discharging. But of course, if you start discharging a vehicle, then basically the vehicle becomes, or actually the vehicle and the charging station combination becomes a distributed energy resource, a so-called DER. And DERs need to conform to local grid codes that tell the station what to do in the case of grid anomalies. Well, there are several protocols that grid operators can do to configure these grid codes. Common ones are the IEEE 2030.5 or the IEC 61850. And we added messages to OCPP to provide support to transfer all these kind of controls that these other protocols can specify to send these controls to the charging station. So, for example, you can get all the nameplate information from the inverter, and you can send default controls and scheduled controls of all kinds of curves, frequency droop curves, etc. And as some of you might know, there is an update underway from ISO 15118-20, the amendment 1, which is going to support the setting of DER controls at the inverter of the EV, which is needed in case you do AC bidirectional. Well, this is also already part of OCPP that we take into account, that you can use this and provide these settings for the inverter in the EV. Then something entirely different, but certainly very important for certain markets, especially the Asian market. That is support for battery swap stations. Because we see that for electric scooters and three-wheelers, a lot of them use swap batteries. And so there are swap stations to provide these batteries. And it was difficult to manage them by OCPP because we didn't have a way to deal with the swapping. But now we have a new message called the battery swap request that you can use to exchange a battery. And then the actual charging is just managed by the regular transaction events of OCPP. But it's no longer the transaction event that is built to the user, but it's the battery swap request that is built to the user based on, for example, the percent of state of charge difference between the old and the new battery. We had contact with several suppliers of these swap stations while creating this use case. And we also made it in such a way that you can also use it for example, a Neo swap station if you want to do that, because it really doesn't matter whether the battery is swapped by hand or whether it's an automatic action on the OCPP level. It doesn't matter. And you can even have a system that does swap in first and then swap out, or the other way around. both will work within OCPP. So I think we have a flexible system there. Okay, so now I reach at the end of my talk about the details, and I think I should give the floor back to Jacob. Jacob, go ahead.
Jacob, I think we can't hear you, so maybe you can check your
It's not
microphone.
possible?
Yes, now it works. Yes.
First try. Okay, and thank you very much, Frank, for the perfect overview. I will try to summarize it a bit. So coming back to the slides you already have seen about the evolution between 2.0.1 and 2.1. You see here, maybe Frank, you can just click once, that there are quite some things, so to say, enhanced but not changed that much. That means the first step for your effective OCP 2.1 implementation is indeed already implementing 2.0.1. And if we now looking into the what if you have an existing 2.0.1 implementation and want to upgrade to 2.1, what are the changes you have to actually do? So we at Vector, we already did so. So I can tell you a few words about this. Maybe Frank, go to the next slide. So essentially, if you just wanted to upgrade the existing functionality, this is a fast and straightforward upgrade. So you don't have to like reprogram or re-implement your whole system, but rather change some key things, and then you are already there. Because the general concept on the general format of the messages remains the same. So the essential things you have to do is you have to add a new WebSocket subprotocol version for the WebSocket handshake. This is normally pretty fast. And then you have to use the updated schemas. And because most of the new features are using optional fields, you are then already able to send for your existing functionality, send OCP 2.1 messages. And after this, you then have now unlock the full potentials of the new features we are adding with OCP 2.1. So it's definitely then, and you can implement them one by one, and you don't have to have the big bang thing at the start. To be successful here, I think a good architecture is always a key part. So I can tell you what we are doing at Vector to make this, to ensure this. So we have mainly added a layer between the OCPP messages and the business logic. This is called here OCPP core on the slide. So what we are mainly doing is we are translating different OCP versions to this abstract data model. And then our business logic works on this abstract data model, generates, for example, the response, and then maps this then back into the specific OCP version, and then this message is sent to a charging station. Now, by doing so, we made sure that we don't have to adjust our business logic when we want to support newer OCP versions. And one thing I think we also see more and more in the field, it's really important that we generate the OCP messages from the OCPP schemas. So with every OCP version, OCA also released the JSON schemas, and then you can generate the classes from them, and then you don't have to like type them by hand. So to summarize it all, we tried to make sure, and at least what we saw at Vector, this is also the case, we tried to make sure that we have a seamless transition from OCP 2.0.1 to the new version, OCP 2.1. But what we are also seeing is that the e-mobility market, it's still evolving. It's still a new market. There are new features around the corner, of course. and therefore it's really for us important that we can publish new OCP versions and to make the market able to implement these new OCP versions without huge migration risks and effort. What we think we cannot do, or it's not feasible to do so, is to add new functionality to existing versions. This really slows down the implementation and the writing of the standard. So we're definitely going for adding new features in new versions. So this means I think it's now already a good time to start implementing and to get your heads around the new OCP specification. You can download it on the website. And we are also discussing this, of course, in the OCA. So in case if you have any questions and they are consider joining the OCA, and if you have joined the OCA, you can ask questions on the mailing list, and you can also ask questions in meetings. So we really I want to make sure that that every question is asked there and answered, of course. So this is from our side there. So I will hand over to Hannah.
Yes, thank you for presenting, Jakob and Frank. So now it's time to start the Q&A session. So as already mentioned, you can post your questions in the question box on the right side. And we have also two panelists today, Jesse and Robert, who join us to answer your questions. So when you're ready, you can now turn on your camera, of course. You can start turning on your microphone, and maybe you can introduce yourself. Maybe you can start with Robert.
Hi, Rodrigo. I'm a technical evangelist at Pionix. We lead the development of Everest. I've been at OCA for 11 years already, been active. Joined after Frank was here because we're one of the godfathers. But and we've implemented OCP 2.1 already in Everest as well. Did the first plug fest in the US, end of January, which was surprisingly successful. It's super easy to migrate from 2.0.1 to 2.1. It's easy to find where the differences are, but the differences are so small between the core of 2.0.1 and 2.1, it almost feels like they directly work out of the box. We had to make sure that we did some architectural changes. The biggest issue we found, we had forgotten to implement the on the WebSocket level, the not implemented feature for new messages that would come in that we hadn't supported yet.
Okay, thank you. Maybe Jesse, you also want to talk a little bit about yourself?
Hi everyone, I'm Jesse White. I'm the co-founder and CTO of RelyOn, and at RelyOn, our mission is to help improve the reliability of EV charging networks. So a big part of that is helping stay on top of the latest standards and advocate for vendor-neutral standards like OCPP. So happy to be here. I guess I've been part of the OCA for a year, not 11 years like Robert, but new players here. We're lucky to be paired with Robert and the Pionix team to be able to test OCPP 2.1. So can echo a lot of the statements there that it was easy to migrate or add support for 2.1 in addition to 2.01 with the new message types. So that was nice to see. And it was cool to see open source implementations out there as well that folks can readily test with and work to implement their stack there too. So happy to be here.
Yeah, all right, thank you. So let's dive into the questions. The first one is about DER control, so about DER control details. Are you saying that every message that IEEE 2035 can send has an analog message that can be sent in OCPP?
I guess I should answer that. More or less. That means every DR control that you can set via the IEEE 2030.5 protocol has its counterpart in OCPP. So 2030.5 also has all kinds of other messages for metering and start-stop transactions, things like that, but they're not relevant for us. It's the DR control settings and the nameplate information, and that's all covered now also by OCPP.
Yeah, all right. Then let's go to the next one. Electric gas station consumers want charging as fast as possible, so they want to minimize the time at the gas station, of course. So why would they want bidirectional, pulling range out of the car? I don't know who can answer this one.
Of course, if you are if you are on a road trip, you need to charge twice to get to your location. You want to charge as fast as possible. That is not the use case for bidirectional charging. Bidirectional charge is probably more on locations where you're staying longer. I don't foresee this being used on hyperchargers. But yeah, if there's a problem with the grid operator is willing to pay a lot, and otherwise the fuses will blow and the charger won't do anything anymore. Maybe there's a corner case where this will happen, but I also don't foresee this happening on a highway location.
Yeah.
Yeah, I also expect this will, yeah, it's more likely use case for AC charging, or at least slow charging, let's call it that way. But of course, yeah, for those who are a bit into the topic, they will know that DC charging is easier because the inverter is in the station and you can better control that. And in AC charging, the inverter is in the vehicle. And then you need the new 1511-8-20 amendment in order to control the inverter in the vehicle. But the technical capabilities are there.
All right. Yeah, thank you, Frank. Okay, so let's have a look at the next question, which is about transaction limits. So what happens when you hit the transaction limit? Will it end the transaction or pause it?
When you hit a transaction limit, then basically at that point it will, depending on what stop point you have set, it will end or pause the transaction.
Mm-hmm.
So you can configure that how you want to have that.
Yeah, so you can choose yourself. Yeah, all right. Then we got a question about authorization updates. So what flexibility are those new features providing? Can you explain a little bit more?
Sorry, what update did you say?
Yeah. It's about authorization updates, so the new features for
New features for authorization.
Yeah.
Yeah, we added a number of new token types that you can use for authorization. So now we have I think also the auto charge and VIN numbers and things like that you can use for authorization. But I think the most important part was the yeah, basically the direct payment authorization, because there are many charging stations already that have integrated payment terminals, but they have needed to use kind of custom solution for that. They usually had data transfers or custom data extensions to deal with that. And now that's all integrated into the OCPP messages. And yeah, basically we can put a lot of that information in the ID token info, the additional info of an ID token for those who are familiar with the subject. So we have identified a whole standard set of parameters that you can provide that are relating to direct payment cards.
Yeah, all right. So let's go to the next one. Is anyone hosting a publicly available 2.1 compliant charge point or simulator so that you could do interoperating testing via internet?
My assumption here is that the easy solution is to look at Everest. The Everest open source project now supports 2.1. It is still in the development branch, but I just learned today that it is going to be merged into the master branch. So the new release from next month will already have 2.1 in the master branch. So you can easily take Everest, run it in a Docker container, and use that for testing against your CPMS. If you want to test a charging station against CPMS, I'm not sure if there's anything available yet. I just asked the question today on the Mobility House OCPP library, for example, that also is still lacking 2.1 support at the moment.
Like in,
But maybe we can also point out here to the Plugfest. OCA is hosting like 3, 4, 5 times a year. So actually, I don't have the next date right at my head, but there have been already 2 Plugfest, one in September last year and one in January, where also, of course, at the time, I think it would not with the public published or the finalized specification, but there were already the first interop tests between CSMS and charging stations at the OCA Plugfest. And I assume that will also be the case for the following Plugfest later this year.
just echo a bit of what Robert said there. Can agree. We used Everest for our testing for OCP 2.1. We hadn't used it before. It was relatively easy to compile. Started in a Docker container and get it up and running, and then vet our solution with it. So that was good. Then once we got to the Plugfest, things worked rather smoothly there as well. So that was nice to see. And then the Node-RED UI on top of it too makes it fairly easy to control. So good tool there for sure.
Mm-hmm. All right. Then a question which maybe Jesse can pick up. So did Reliant already implement 2.01 before 2.1? Or what was your biggest challenge when you implemented 2.1? So maybe you can explain a bit about that.
Yeah, good question. Actually, we were actually in the process of implementing 2.01 when the draft for 2.1 was released. So we were actually able to kind of implement both of them in parallel as we went through. Luckily, there was again, a lot of the new features are optional there in 2.1, so we're able to do that both of them at the same time. And yeah, it went rather smoothly. So that was nice.
All right. Thank you. The next question is, how can we encourage EVSE suppliers to provide firmware updates?
That is if you are a CPO and you want your supplier to provide you with 2.1, you need to start asking the question. You just need to start asking, hey, I need this functionality. I want this kind of functionality in a charger that isn't available in 2.01. When are you going to supply us with 2.1? Because I'm assuming the more customers of the charger manufacturer are asking for 2.1, the sooner they will start implementing it. And it's probably the same for the CPMS providers. If you're using a CPMS SaaS provider or you're using a white label version of a CPMS, start asking your supplier when will they have 2.1 available.
I think in the end it comes from the use cases. If you want to use OCP with bidirectional charging, you simply have to upgrade, and then there's this strong need. If the charging station manufacturer wants to build a bidirectional charging station, then they simply have to. So definitely, I think we will not see like all charging stations in the field updated in the following months, of course. But when time passes, there will be more and more charging stations supporting this, and the CSMS is supporting this.
And I agree, Jacob. There, it's a new functionality. If you're just asking for can we get 2.1, and you don't need the new functionality, probably nothing happens. But if you need it for credit card payments, you need authorization of transaction limits. If you need bidirectional charging, if you need any of the new functionality, you will need to migrate. You will need your supplier to migrate your charges to 2.1.
Yes.
Yeah, I guess on that, there's cool new use cases there to better support like fleet operators as well, right? Automatically resuming the transactions there, for example, after going offline. That's a huge one there for anyone that's using chargers for fleets. So, for that case, I'd definitely advocate for 2.1 to be implemented by the OEMs.
Yeah. All right. So let's have a look at the next question, which is about the receipt functionality. So can this functionality also be used if the payment terminal is integrated on CPO or OCPI level?
Yes, I think this refers to when you have a standalone payment terminal, where you have, for example, a payment terminal booth that for an entire charging plaza or a group of charging stations. And then usually this payment terminal communicates via OCPI with the CSMS. And that is indeed supported by our use cases. So we can have an integrated payment terminal in the station, or we can have a standalone payment terminal, or we can have the receipts generated by the station, or have the receipts generated by the CSMS or by the terminal. So all these different possibilities are covered in our use cases.
Yes. Okay. All right. Next question. What is the percentage use of two-point run in electric/gas stations, in fleets, and in residential locations? Because the person who asked the question wonders if the features features are geared to electric or gas stations and fleet locations, and that no payment terminal is needed at homes. So I don't know if you can, maybe Frank, you can pick this one up.
Yeah, at least I can start with it. Yeah, of course, if you're talking about a home charger, yeah, you don't have to deal with the payment terminal, of course. But maybe not right now, but in the near future, you might want to be interested in doing bidirectional charging at home. Because if your own vehicle is parked there for hours at a time, yeah, that might be a good case that you want to earn some money by providing some frequency support or something like that. So for those cases, I think it might be interesting to use 2.1. And I think Jesse already mentioned that there is an advantage for fleet operators. I don't know what kind of percentage of use it will be. Of course, we're now just starting with 2.1, but I would not be surprised if 2.1 is going to take over 2.1 faster than we think.
Yes. All right.
Especially with how small the migration is to go from 2.0.1 to 2.1. I'm almost expecting that almost every implementation that is 2.0.1 will soon do 2.1 without the extra features. I mean, that will follow after that, but that depends on how you're doing fleet. But even a small thing like the priority charging, Frank, if somebody wants to do priority charging, it's such a small feature, but it's so super user friendly if you have that implemented. Yeah, I wouldn't be surprised if it's a lot quicker to migrate 2.0.1 to 2.1 in the field.
Yeah, I really think so. So, I mean, that was also the feedback we quite often got from the market, that it's hell of a job to migrate from 1.6 to 2.0.1. And to a certain extent, I would agree with this. And I think we all have experience while upgrading, and it's really simple. So, yeah, I would also expect and I really hope that it's going much faster than for 2.0.1.
Yeah, all right. So let's have a look at one last question, and I think that then it's time to wrap up. So the last one is, I've read before that features in the OCPP protocol are optional to implement. Is this true for all features, or are there parts of the OCPP 2.1 which are mandatory to use if you want to be able to say that you comply with 2.1?
Well, if you look at the core profile, for example, I think, but maybe Jacob or Robert, you should help out. I think every new thing for 2.1 is optional. So you can publish in your device model, for example, whether you support transaction limits and which transaction limits you support. You can also report if you do not support any. And the same goes with the charging profiles. You can specify whether you are supporting a local generation or a priority charging profile or not. So that's just the strength of the device model, where you can really configure, and the configuration can be read-only, where you say, okay, sorry, you cannot change it. This is what I support. But in many cases, it can also be changed by the CSMS, and then the operator can decide whether that support is going to be activated or not.
Yeah, I'm just top of my mind. There's roughly 6 requirements in the existing core use cases added. So you just need to check these 6, and those are probably almost common sense that you needed to do these. All the other indeed functionality. In the security part, there's some new functionality for -20 certificates. If you don't do the -20, you don't even need to do anything. What was the other thing that came to my mind? The status notification is going to be replaced by event notification, but you are still allowed to do status notification. Of course, the spec says please update to event notification, but even if you don't, you are still within the spec. I'm not sure what will be in the certification in the end, but that might almost be the biggest change. If there's something there, it's the status notification no longer being there and being replaced. You know, top of your head, Frank, if that is how does that look in the certification profiles?
It's still allowed in in the test cases, but you will get a warning that it's deprecated. And in OCPP 2.2, they will no longer work. So you better update it now.
Yeah. So even that, if you don't upgrade that, you still comply. So there's nothing you really need to do. Yeah.
Yeah, but speaking about certification, so we are currently starting to draft all the new test cases we have to add for OCP 2.1. So there is currently no certification available yet. So currently you cannot show that you comply to OCP 2.1, but the work has already started, and I would expect it to be much faster than the certification for 2.0.1 because we can build on a strong basis led out by OCP 2.0.1. So I would expect that in the near future, so not in 5 years, we will have also certification for OCP 2.1. And at that point, you then can also show that you comply to the newest version of OCPP.
And
Yeah,
that will
because
also, for people implementing, that will also bring OCT, the test tool, will also a lot quicker have support for 2.1.
Yes.
That took a
yes,
while
because we already.
new tool. Yeah.
Yes, sorry. I just want to say we have already written most of the test cases. We did that partly in parallel with writing the specification, and I think they are going to go in an internal review within the compliance or technology working group next month or so. And then after that, we will start updating OCT to also support 2.1, starting with the core profile and then later on the other messages. So yeah, you should not have to wait too long for that.
All right, yes. So it's time to close this webinar for now. I would like to thank all our speakers and panelists for joining and for sharing your insights. And also thank you for everybody who joined today, for asking all your questions and for bringing your input. If you have any more questions for us, you can contact us on Causeway or at info@openchargealliance.org, and then we will come back to you and answer your questions. So we hope to see you again soon at one of our webinars or live events. If you want to stay up to date, you can check the event calendar on our website, or you can follow us on LinkedIn. So for now, it's time to close the session. Thank you again for joining and have a good day.
Hey, thanks for organizing.
Thank you. Bye-bye.
Bye.
Thank you. Bye.
Bye.